So we're back to this overview of energy metabolism where we looked at how protein, glucose, carbohydrates, and fats go through these three major steps: conversion to acetyl-CoA, through the TCA cycle, and then through the electron transport chain. What is another concept here that we want to look at is the idea of the concept of being fed and then fasting. Fasting is more complicated, so I'll talk about being fed first. Being fed is really not that difficult because we kind of know what happens. If you overeat, you eat soda all day long and candy and butter and just a lot of calories, we know what happens. We get fat. So the concept that when we put more of these energy-yielding nutrients into these processes, you might think, oh, this gives us more energy just by eating more of these substrates. But it doesn't work that way. When you convert everything to acetyl-CoA, it will not allow too much to go into the TCA cycle. When we have more ATP than what we need, the body says, slow this whole thing down and don't just let everything keep going through the TCA cycle. And what happens is the acetyl-CoA, the amount of acetyl-CoA starts building up. And we get too much of what we need, so the body will convert that over here to form more triglycerides, which is just the scientific word for fat. We already knew that. We eat too many calories, we get more body fat. But now we can see why. These things all get converted to the same molecule, acetyl-CoA, and that can be converted over here to fat. And it's why we can gain body fat by eating too much protein, too much sugar, or too much fat. Okay? And here we think about food fat being broken down and put back up, and it does somewhat happen that way. But the concept is the same. Everything goes to this molecule, so everything can come over here and be converted to body fat, which we already knew. We eat too many calories, we get too fat, or we gain fat. Now, when it comes to the fasting, what happens when I don't eat enough? Again, the first concept we kind of know. We know that if I don't eat as many calories, I'm going to lose weight. And usually I think about losing body fat. So I'm going to break down triglycerides. We're going to send it through the process. So instead of this coming from my food, it's coming from my body fat. But there's really two concepts that we need to think about when we think about fasting. We not only have to think about energy, which we can get through this process, we also must think about getting glucose. So there are some parts of the body that cannot use these pathways. They can only use these pathways for energy. One of them, for example, is the brain. The brain will only use glucose for energy. So we've got to figure out a way to get glucose for the body. Now, one way that we can get glucose is from our stored carbohydrates. Glycogen, okay? Glycogen is the stored form of carbohydrates, and that can be converted to glucose. Did you eat breakfast this morning? And did you eat today? Have you eaten yet today? If you haven't eaten yet today, what you're doing for your source of glucose is going to be from your glycogen. We store it in our liver and in our muscles. And our liver muscle glycogen can release its glucose back into the blood. It gets transported to the brain, and it's going to be our source of glucose for the brain. So if you skip breakfast sometime and go through the night, that's what's happening. We have enough glycogen to last about a day. Not quite a day, but pretty close. So we have enough to last, but not a long time. Let's say that you've been sick, or maybe you're deciding to just not eat for a day, or you're on an Atkins diet where you're really, really low carbohydrate. And so your glycogen is gone. Now that one's more complicated, because the first one we have stores, we release it, meets our glucose needs. But now we still need glucose. The brain still needs glucose. So we have to figure out a way to use this pathway right here. Get pyruvate and convert it to glucose. Now we could use glucose, but that's not going to work. We're not going to just use it and then turn it around. So that's not going to be. We need to use this pathway right here. So we want to take a look at those things that will bring us pyruvate. Those things that go to acetyl-CoA cannot go back up. So we've got to look at those things that will be converted to pyruvate and can be converted up there. Now we could use glycerol. Glycerol can be converted, but unfortunately every time we get a glycerol, we need two of them, because we've got to take two of these to convert it up to a 6 carbon. We get all of this fatty acid. And the body just doesn't want to be overwhelmed with fatty acid to get that every one little molecule of glucose. This is not a good source. Fat is not a source of body glucose when you need glucose. We then must go look over here. Amino acids. Our source of glucose when we are not eating enough carbohydrate will be amino acids are protein. So we'll actually break down our body proteins to feed our brain's glucose. That seems a little odd, but this is the pathway that is there. And why we don't really want to go on starvation diets, and why someone can die pretty quickly if they don't adjust things to go through that pathway. So conversion, when we need glucose, our first source is going to be glycogen, and we have enough to last about a day. After that is gone, then we're going to go to other pathways, and the primary one is going to be body protein. It could be food protein, and you can go on these low carbohydrate diets high in protein, but we all are still going to use some of the body proteins, and so we would lose lean body mass to feed our brain primarily glucose. So the energy of the concept of metabolism for feasting, when we eat a lot, we store it as fat, and then fasting, we can use this as energy, but we also need to be worried about glucose and how we're going to feed the rest of our body glucose that needs it.